Hello and welcome to another session in mathematics. In today's session, we'll be looking at matrices. But before that, let us take a review of our previous lesson. Welcome back. In the course of today's lesson, we'll be looking at transpose of a matrix and then determinant of matrices. Determinant of matrices. So, let us start with the transpose of a matrix. The transpose of a matrix A, denoted by A raised to power T or A prime, is interchanging its rows and column. That's what it means. So, for instance, if we have our matrix A to be equal to A, B, C, D, E, F, G, H, I, J, K, L. Then the transpose of A, which is A raised to power T, is then equal to making the rows, the first row to be the first column, making the second row to be the second column, and making the third row to be the third column. What do I mean by that? We have our first row here to be what? A, B, C, D. Then it becomes our first column when it comes to the transpose. Then our second row is E, F, G, H, and that becomes E, F, G, H. Okay, and then we'll have I, J, K, L as our third row. Then our third column here will then be I, J, K, L. Okay, we've succeeded in getting what? The transpose, in taking the transpose of matrix A. So that is what we need to know about what transpose. So let's take some examples. Assuming we are given A to be equal to the matrix, let's say 1, 5, 3, 2, 4 minus 2, and we are asked to find 80. Find transpose of A. Okay. Transpose of A, like I told us, is just to interchange the rows and columns. Just interchange the rows and columns. So our transpose of A will then be equal to the matrix. This becomes our first column. So we have 1, 5, 3, and then this becomes the second column. We have 2, 4, and minus what? 2, and that's just the answer. Okay, that's the transpose of a matrix. So let's go over to determinant of matrices. Determinant of matrices. Okay, we start with determinants of 2 by 2 matrices. 2 by 2 matrices. Okay, I told us that we have 2 by 2 matrices, and also we have 3 by 3 matrices, and 2 by 2 is just the order of what? A matrix. And matrix that is that has the same row and the same column, we call it what? Square matrix. Is that correct? So for 2 by 2 matrices, if we have A to be equal to, let's say, A, B, C, D, this is a 2 by 2 matrix. It has what? Two rows and what? 2 columns. Okay, so the determinant of A, written as this, or you can write it to be, let's say, determinant of A, anyone you choose, it's correct, is just A times D minus B times C. So first of all, you need to write it like this: A, B, C, and D. That's the way it should be. And then this is what? A multiplication. Okay, so what do? We have A multiplying D, AD, minus B times C, which is BC. Okay, that's just what it means when we talk about what? The determinant of a matrix, a 2 by 2 matrix. So it means what? The number here times the number here, minus the multiplication of the number here and the number here. Okay, so let's take some examples to illustrate that better. If we are given A, that's number 1, A is equal to 2315, and B equal to minus 3, 2, 6, and minus 4. So to find the determinant of A, we then have A to be equal to, we have 2, 3, 1, and what? 5. Is that correct? And that will give us 2 times 5 minus 3 times 1. Do we understand? Okay, so therefore we have 2 times 5 is 10 minus 3 times 1 is what? 3, and that will give us what? 7. That's the answer. Then for the determinant of B, we have determinant of B to be equal to minus 3, 2, 6, and minus 4, and that will give us minus 3 times minus 4 minus, then we have 6 times 2, 6 times what? 2. Minus 3 times minus 4 will give us what? 12, and 6 times 2 is also 12, giving us our answer to be equal to what? 0. So the determinant of B is equal to 0, while the determinant of A is equal to what? 7. So that's how it works. Okay, so let's go over to determinant of 3 by 3 matrix. 3 by 3 matrices. We've looked at determinant of 2 by 2 matrices, so let's go over to determinant of 3 by 3 matrices. Determinant of 3 by 3 matrices is given to us if we have A to be equal to A, B, C, D, E, F, G, H, I. Okay, if this is matrix A, then the determinant of A is then equal to, bring out your first entry here, the first element, which is A. Then when you bring out your first element, which is A, you then cancel the row in which it falls and cancel the colon too. Okay, so you cancel the row in which this first element is and cancel its what? Colon. Then the remaining letters, you then write them down. So what is remaining here? We have E, F, H, I. Okay, then minus what's the second entry? B, into, you also cancel its colon and its row, and what will be left to be DG, and then FI, then plus, what's the next entry? C, into, cancel everything here and everything here. What's left? DE and GH. So we have DE, GH. So the question is, how did we obtain these signs? Okay, the first line is plus, the second line is minus, this is plus. Okay, and then when dealing with this is minus, this is plus, this is plus, this is minus, this is minus, this is plus. Okay, so that's how it works. Okay, so at this point, what do we have? Our then the determinant of A will then be equal to A into, we now apply the normal procedure we use in 2 by 2 matrix. So we have E I minus F times H, which is FH. Is that correct? Then minus B into D times I will give us DI minus G times F, which will give us what? GF, plus C into D times H, DH, minus G times E, GE. Do you understand? That's how a 3 by 3 matrix works when it comes to what? The determinant of a 3 by 3 matrix. So let's quickly take some examples to explain that better. Okay, question number 1 on the screen. Given P to be equal to the matrix 2, 3, 7, 5 minus 2, 0, 4 minus 3 minus 1, find the determinant of P. Find the determinant of P. Let's start. First of all, this is a 3 by 3 matrix. So the determinant of P will then be equal to, pick out the first number here, 2 into, you cancel the first row and the first colon, what is left? Minus 2, 0, minus 3, and minus 1. So we have minus 2, 0, minus 3, and minus 1. And remember, this is plus, this is minus, and this is plus. Is that correct? So therefore we then have minus 3, which is the next element. We cancel its colon and its row. We'll be left with 5, 4, 0, minus 1. Okay, and then we'll have plus the last number, which is what? 7, into, when we eliminate this and this, we'll have 5 minus 2, 4, and minus 3. Any confusion? So that will lead us to having our determinant of P to be equal to 2 into, remember we are multiplying, so we have minus 2 times minus 1, minus 2 times minus 1, minus 3 times 0. Then we have minus 3 into, we also multiply, 5 times minus 1, minus 4 times 0, plus 7 into, multiply out, 5 times minus 3, minus 4 times minus 2. Okay, so what do we have? We have 2 into, minus 2 times minus 1 will give us 2, and 3 times 0, minus 3 times 0 will give us 0. Okay, minus 3 into 5 times minus 1 will give us minus 5, minus 4 times 0 is also 0, which is minus 0. Then we have 7 plus 7 into 5 times minus 3 is minus 15, and then minus 4 times minus 2 will give us a positive 8. Okay, then we have 2 into 2, minus 3 into minus 5. So 7 into, and what do we have here? Minus 15 plus 8, and that will give us minus 7. So let's go over to the next page. Let's multiply out. 2 times 2 is 4. Okay, then minus 3 times minus 5 will give us what? Plus 15. We have 7 times minus 7, that will give us minus 49. Okay, so 4 plus 15 minus 49 will give us minus what? 30. Therefore the determinant of P is equal to what? Minus 30. That's how the determinant works. So thank you for being part of today's class. I hope you really enjoyed what we did. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with transpose of a matrix, and we've actually studied about determinant of matrices involving 2x2 and 3x3 matrices. We'll stop here today, so do well to use the lesson note on the platform for better information on what we've just done, and feel free to drop your questions or comment on the comment section. Till we meet again, stay safe and bye.